everyone, it's Mrs. Martello. We're going to look at section 5.1, and in this section we're going to start solving systems of linear equations. So this whole chapter is all about systems, and a system is just when it's a set of two or more linear equations in the same variables. So you just have more than one equation and you're solving them together. So here's an example where we have two equations, x plus y equals 7, 2x plus minus 3y equals negative 11. So that's just an example of a system because there are two of the equations in both x and y. Now the solution of a system of linear equations in two variables is an ordered pair that is the solution of each equation in the system. So it's one ordered pair that makes both of the equations true at the same time. So let's look at example 1. In example 1, we're checking solutions. We're going to tell whether the ordered pair is a solution of this system of linear equations. Let's look at A. We want to see if the 0.25 makes this system true. So I'm going to take the 0.25, I'm going to plug it into one equation at a time, and if it makes both of them true, then the answer is yes, it's a solution. But if just one of them is false, or if both of them are false, then no, it's not a solution. So let's check it out. We're going to substitute in the 2 for the x and the 5 for the y. Let's plug it in the first equation here. X plus y equals 7. So 2 plus 5 equals 7. Yep, that one's true. Let's check the second equation. 2x minus 3y equals negative 11. 2 times 2 minus 3 times 5. Does that equal negative 11? Yeah, this would be 4 minus 15. Yeah, that would be negative 11. So that one works. So because the ordered pair 2, 5 is a solution of each equation, then it's a solution of the linear system. So again, it just has to make both equations true. Let's try letter B. Negative 2, 0. Let's see if this is a solution of this system here. We're going to plug it into one equation at a time. Just be careful, make sure you remember the negative 2 is the x and the 0 is the y. So let's plug it in. We want our y is 0 equals negative 2 times negative 2 minus 4. This would be 4 minus 4. Yep, that one equals 0, so that one's good. But we're not done yet. Remember, it has to make both of the equations true. So let's check out the second one. If I plug it into the second equation, 0 equals negative 2 plus 4, no, I would end up getting 0 equals 2, which is definitely not true. So the ordered pair negative 2, 0 is a solution of the first equation, but it's not a solution of the second equation, therefore it is not a solution of the system. All right, so you just want to take the point and it has to make both true. That's example 1. Let's go over here and we're going to take a look at the next page. Now we're actually going to solve these systems. So instead of me giving you a point to test out, say, hey, is this point true or false? I'm going to ask you to find that solution point. So the solution of a system of linear equations is the point of intersection of the graphs of the two equations. So what we're going to do is we're going to solve by graphing. We're going to graph the two equations. We're going to see where the two lines intersect, and that point of intersection is the solution. So here are our steps. We're going to graph each equation on the same coordinate plane. We're going to find the point of intersection, and then we're going to check it, plugging it in, making sure that it actually makes both equations true. Let's look at example 2. We're going to solve the system of linear equations by graphing. Our first equation is y equals negative 2x plus 5, and our second equation is y equals 4x minus 1. Let's graph each equation. So let's start with the first one. We're going to start at our y-intercept. Remember, you always start at the y-intercept when graphing from y equals mx plus b. We're going to plot 5 here on the y-axis. Then we're going to use our slope. Remember, rise over run. So we're going to go negative 2 over 1, which means I'm going to go from the 5 down to right 1, down to right 1, down to right 1. And this is our first line for y equals negative 2x plus 5. Let's take a look at our second equation, y equals 4x minus 1. We're going to start at the y-intercept here of negative 1. So plotting that here on the y-axis at negative 1. And then our slope of this line is 4 over 1. So from this y-intercept, we're going to go up 4 and right 1. We could do it again, up 4 and right 1, and draw your line here. And then you can see clearly that this point right here where they are crossing, that is the point of intersection, and that is the point 1, 3. That would be our solution. So the graph appears to intersect at 1, 3. Let's just double check to make sure that it makes both of the equations true. If I plug in 1, 3 into the first one, it works. If I plug it into the second one, it works. Therefore, the solution is 1, 3. So again, you're just looking for that point of intersection. I just want to talk about what they're showing you here. This is how you can get the solution in your graphing calculator, and I want to show you how to do this in the handheld graphing calculator. You can also use Desmos, but I'm going to show you how to do it on my TI graphing calculator. So if you don't have one of these, that's okay, but if you do have one, it is a nice tool to have for Algebra 1. So let's take our two equations. If you notice, I pressed y equals here on the left side of the bottom of the screen, so I could type the equations in. Let's do one at a time. Negative 2x plus 5. Our second equation is 4x minus 1. I'm gonna hit the graph button here. And what you should notice is the graph on my screen looks exactly like the graph that we drew. Now I can try to estimate this point here by looking at the screen, but I can also get my calculator to tell me this point. So to do that, I'm gonna hit second, and then above the trace key is calc. That's where I wanna find my option for calc. Then the point that I'm looking for is the intersection point. So I'm gonna use number 5 here, pick number 5. Then it asks me some questions. Is the cursor flashing on the first curve? Yes, it is. That was our first equation. Hit enter. Now look at the cursor. Is it flashing on the second curve? Yep, that was my second equation. Hit enter. Then it says you can guess. You can move your cursor. I'm going to hit the right arrow. Try to get as close as I can to that point. I can't get exactly on the point because of the pixels of the screen, but just get close and then hit enter. And look at that, our intersection is 1, 3, and it tells us our solution from the calculator, which is a nice feature to use to check. Okay, we're gonna do some two examples of these together. So we're gonna look down at the bottom of the page. We're gonna do monitoring progress numbers 4 and 5. So we're starting with number 4. Let's take a look at these equations here. I have y equals 1/2 x plus 3 and y equals negative 3 over 2x minus 5. We're going to graph one at a time, and let's find the point of intersection. So let's start with our first equation. We're going to start at the y-intercept, which is positive 3. Plot your point. And now from here, we're going to use our slope. Our slope is a fraction as rise over run. So I'm going to rise 1, run right 2. Rise 1, run right 2. I can do it again. Rise 1, right 2. I can go the other way as well. I can go down 1, left 2. Do it again. Down 1, left 2. One more time. Down 1, left 2. And for these, it's easiest to have as many points as you possibly can, because then it's easier to see that point of intersection. Sometimes it's hard to draw a straight line through just only 2 points. The more points you have, the more precise your line is. Great, let's graph our second equation. We're gonna start at our y-intercept of negative 5. 1, 2, 3, 4, 5, down on the y-axis. Plot your point. Now we're gonna use our slope. This is negative 3 over 2. So I'm gonna go down 3, right 2. So 1, 2, 3, right 2. Okay, I'm gonna go the other way because I ran out of room on my graph. Instead of going down and right, let's go up 3 and left 2. Let's do it again. Up 3 and left 2. Oh, and we can see there, that's where they're gonna cross. One more time, up 3 and left 2. Let's draw our line right through these points here. And finally, we're gonna state the solution, and the solution is this point right here, this point of intersection. So our solution is the point right here. This is 1, 2, 3, 4 to the left, so negative 4 and up 1, negative 4, 1. That would be our solution. Now I can check my work by taking this point and plugging it in and making sure that it actually makes both of the equations true. So I'm going to do that on this separate piece of paper over here so I can save my graph paper. So my first equation was y equals 1/2 x plus 3. Let's plug in the point. Remember, we're plugging in the point for -1. This is the x and the y. Let's plug it in. -1 equals 1/2 times 4 plus 3. -1 Oh, I switched it up. Sorry. This is -4, +1. I wrote it down wrong. That's my mistake. So -4, +1. That looks better. +1, -4. I was wondering what was going on. It wasn't going to work. Okay, so we're plugging in the point -4, 1. So 1 equals -2 plus 3. Yep, we get 1 equals 1, so that one works. Okay, let's try our second equation, which was y equals -3 over 2x minus 5. Again, we're plugging in this point. Let's see if it works. So we have 1 equals -3 over 2 times -4 minus 5. So this would be 1 equals negative and negative make positive. 3 over 2 times 4, that would be 6 minus 5, and I get 1 equals 1. So I know that this one works too, and I found the solution. Okay, let's make sure we know how to multiply this fraction and this constant term here, this integer. So if I have -3 over 2 times -4, which technically is over 1, remember you can just multiply across the top and across the bottom. So here I would get 12 over 2, which would be 6, and that's what I said here. Okay, we're going to take a look at one more example. Let's take a look at monitoring progress number 5. Now, with both of these equations in this problem, we should notice that they are not in slope-intercept form. So now we have a choice to make for this one. We can either, 1, solve the equations for y, and make the equations y equals mx plus b, and that's what we did in section 3.5. Or our second option is we can find the x and y intercepts. Find the x and y intercepts. And remember, this is when you plug in the zeros. Plug in x equals 0 and y equals 0. And just to remind you, this is from section 3.4. And that's totally up to you. However you decide, whatever you think is better, whatever method you prefer to graph, it's totally up to you. Me personally, I think I'm going to solve for y in both of these equations. I think it would be easier to graph if I use y equals mx plus b. So that's what I'm going to do. I'm going to take my first equation here, 2x plus y equals 5. Let's solve this equation for y so I can make it y equals mx plus b. So all I have to do is subtract 2x from both sides. And here I have y equals -2x plus 5. That would be my first equation. Let's do the second equation now. We have 3x minus 2y equals 4. Let's solve for y. So I'm going to subtract 3x from both sides. I get -2y equals -3x plus 4. Let's keep solving. We're going to divide both sides by -2. And remember, we want to do the heart method here. We're going to divide this term and this term by -2. So we get y equals, I'm going to keep this as a fraction, but remember, negative and negative make positive. So this will be 3 over 2x. And then we're dividing here. 4 divided by -2 would be -2. And there's our second equation. So now we're ready to graph these two equations. Let me go over to my graph paper here. I'm going to write down my two equations that I now changed into slope-intercept form. We have y equals -2x plus 5 and y equals 3 over 2x minus 2. Let's graph this on the coordinate plane. So let me draw my axes here. and we're going to label our axes x and y. And let's start to graph. Our first equation, we're going to start at the y-intercept up at 5. 1, 2, 3, 4, 5. And then we're going to use the slope. Our slope is -2 over 1. So we're going to go down 2, right 1. Do it again. Down 2, right 1. One more time. Down 2, right 1. Maybe one more time. The more points you have, the easier it is to see the line and to draw the line nice and straight and to find that point of intersection. Let's do our second equation. We're going to start at our y-intercept of -2. And our slope is 3 over 2. So we're going to rise 3, run right 2. And there we go. We found that point already. I'm going to do it one more time. Rise 3, right 2. And I'm ready to draw my line here. Okay, and there is our point of intersection right here. So let's say our solution, this point would be 2, 1. The point is 2, 1, and that would be our solution. Okay, let's do our check just to make sure that this actually does work. So what I'm gonna do is I'm gonna go back to the original equations that we started with and plug this point into the original equations. The reason I'm doing the original equations is because what if I made a mistake when I solved here or solved here and I got the wrong thing? So I want to use the original equations. Let's see if it works. So I'm going to plug in the point 2, 1. Remember, this is x and y. Our first equation from number 5 was 2x plus y equals 5. Let's plug it in. 2 times 2 plus 1 equals 5. Yeah, 4 plus 1 equals 5. This one works. Let's try the second equation, 3x minus 2y equals 4. I'm going to plug in the point, 3 times 2 minus 2 times 1 equals 4. This would be 6 minus 2 equals 4. Yep, that one works as well, and I know I got the point correct.